Okay, good day, everyone. Um, like I promised last week, that next class is gonna be on. Please let me zoom out a little bit. So our next class is gonna be on sorry, not variation, combinations. Combinations. So today we're gonna be starting off with combination. Uh, we're gonna be starting with combination, what they are, and how to use them. Um, Let me give a definition to it. So combinations are the numbers of different ways we can pick certain elements of a set. Let me type that out so that you can take note of that. Combinations are different ways. Different ways. The different ways, or sorry, the, let me put it this way: are the numbers different ways, different ways we can pick certain elements of a set and pick certain element of a set. I hope you can see my screen very clearly or very uh, yeah, very you can have a very good visual to my on my screen. So if that is not seen properly, if my screen is not properly seen or what I'm typing is not properly seen, please always comment in the comment section so as for me to know. Or you can just write to me on Discord on a better way um, to zoom out my screen so as for everybody to see what I'm typing. So that being said, so imagine let me create a scenario. Let's say imagine you want to pick three colors from the basket of 10 different color balls. Let's say you have a situation whereby you have a song and you want to the son came to you and you have a basket of 10 balls of different colors and the son requested for three balls and you want to give the boy three different color balls. If you have to solve this using variations, of course you will say something like say, let me you want to say something like say you want to say something like say v because you have 10 balls, of course, and you have what three. Don't let us forget this. You remember we did something like this with in variations where this 10 is the number of the total number of um numbers, the total number of the total numbers we are having, or different elements we are having. Sorry, excuse me. The total number of elements we are having in a given set. Sorry. Then the three is a number we have to select. You understand, from a given set. So don't let us forget that. So in this case, if you are to use variation, you have something like say v10 3 equals what? Say we say 10 factorial. Of course, it is without repetition all over what? Say something like 10 minus 3 factorial. And this gives what? Let's say this gives from 10 factorial, we have 10 times 8, 9 times 8 times 7. We can make this factorial, of course. So 10 minus 3 is what? 7. So we can say 7 factorial because we have factorial here. So this 7 factorial cancels out what? This 7 factorials. You understand? So we are left with what? 10 times 9 times 8. And this one, if we calculate this, it will give us what? 720. And that is that if you have to use variation. But from this calculation, from the calculation of variation, you will see that variations don't take into account double counting elements. So that is why we have to use combinations in this case, because variations don't take into account what? Double counting elements. So if I decide to use, let me say I want to use this word. Let me go back to the IDE so that I can. Let me say if I decide to use these words, they may sound confusing, but please pay close attention to them. You may write them out. If I say all the different permutations of a single combination are what? Different variation. What does that mean? Let me write it out. All the say different all the different permutation of a single combinations a single combination are different variation. A single combination are what? Different variation. Different variations. What do these words, what do they mean? The combination of these words, what do they mean? Well, we are simply saying this simply means irrespective of the color of balls I decide to pick from the basket, say if I decide to pick say red, blue and green, it doesn't matter which one I pick first or the order at which I pick them. That's what these words are saying here. So I can decide to pick say okay, initially I said let me pick red, say blue and green. So blue and what? Green. Understand? It doesn't matter which one I pick first or the order at which I pick them from the basket. So I can decide to as well say I want to pick green first. I want to pick blue, say red. I can decide to say green, blue, red. Like I said, red, green, blue, red, blue, green, whichever. I can go on and on and on. So the method is all the same, and that means the order is what? Irrelevant. So conclusively, any of the six permutation we just displayed, because we have three here and we are picking at random, we're trying to change the order at which we pick them, which has no relevance to combination. So any of the six permutation we just displayed is a different variation, but not what? A different combination. So this is what we mean when I said all the different permutations of a single combinations what are different variations. Remember that permutation of n number of elements is what? Let me remind you. Let me go back to this. Let me say permutation of what? N number was of what? Of elements is what? N factorial. If you remember, I said something like that. If you can't remember, please go back to the previous video and watch that. So therefore, permutation for choosing green, blue, red balls is what? We can say the permutation of choosing green, blue, red ball is what? P of 3, which is what? 3 factorial. And 3 factorial is what? 3 times what? 2, which is what? 6. So that is why I said uh, that's why I said six that's why I concluded earlier on that six permutations we just display is different what is a different variation but not a what different combination. So observe here that we are simply going to have six variations for any combinations, that is to say six times fewer combinations than variations. So if we decide if we had had the variation to be um, say v uh, 10 3, which is what 720, if you can remember from this calculation here, uh, then the combination will be, so if we since we have this as a variation, so we can simply say the combination will now be what? The combination will now be what? Say 720 divided by 6, because of these what permutations from what I've defined ab initio. So this means that we have 120 ways of selecting which colors of balls to give out. I know at this point it might sound confusing to you, so I don't want you all to get confused with all these terms or terminologies. So if it means to write them down, please do. I want you to know that these lessons are not a one-time view. Please, you can always refer to them. You can always make references, or you can always make reference to previous videos, just to um, you know, just to remind yourselves or remind ourselves of what we've taught and stuff. And that's why I always tell you, I've always been telling you guys that please put down your always write down points. Always write down points. You might not have the luxury of time, or you might not have uh the fortune or whatsoever may deter you from reviewing the previous lesson. You can just pick up your notes and make do have a revision on what has been taught or what we've done in the past and stuff. So you can always make references to your notes rather than going back to previous videos and stuff like that. So let's have a formula for our combination. So let's assume a question goes this way. Say, let me write the question. Let's assume we have a question. Say, um, let's say the question says, what is the? Let me write it in uppercase. What is the? Let's say the question says, um, what is the number? Okay, what is the number of combinations? What is the number of combinations for what? For choosing is the number of combinations for choosing p many, let's say p many elements out of a sample space, a sample space out of a sample space of say n elements. N, let me write that in lowercase n elements. So what if a question goes this way? How would you come about it? Say, so from our previous definitions, how would you attack it, or how would you uh, formulate a formula for this? How would you formulate this question using our previous definitions and terminologies? Well, if you take a look, if you play back our previous definitions or terminologies, or if you have written them down, you can simply deduce that the number of combinations equals what? The number of variations over the number of what? Permutations. This is what I'm saying. We can deduce from the previous definitions and terminologies that the number of, let me write it in lowercase so as for me to differentiate it. So we can say the number of combinations, the number of combinations equals the number of variations, the number of variations equals the number of variations over, let me not say over, let me say divided by say the number of permutations, okay, let's leave it that way. So the number of combinations equals what? The number of variations divided by what? The number of permutations. So this is what we are saying. Let me write it down. This is what we're trying to say. Let me clean this up. So this is what we are saying. This is what I'm trying to say in essence. Let me, so that I can differentiate. And what I'm saying is the number of what combination is the same thing. I think this one is not thick enough. Let me choose. Let me say I'm choosing this. Okay, the number of what combination equals what? Equals the number of variations divided by, this is it, variations. Sorry, yeah, divided by what? Permutations. This is what I'm trying to say. So we can say in a simpler terms, we can say CP, sorry, C combination equals what? We can simply say combination equals say n factorial divided by what? P factorial n minus p factorial. and that is it. That this is the what the formula for what combination. So I want you to write down the formula for combinations so that there won't be any need for you to be, and all these formulas, please be taking note of them. It's important. So let us apply the formula to what we've done before, so we can have so that we can have we can conclude that uh the previous simplification we did is not at fault. You understand? So we can have, we can that will prove our formula, or that will prove that the previous simplifications we did are what are correct. So let's apply this thing. Of course, remember that we are trying to give three color balls out of what a basket of 10 different color balls. So we have the total number n here. N is always the bigger number, and p is always the smaller number. So we learn have what we are picking three. So we are now going to say that 10 factorial divided by what? 3 factorial from the definition. Remember, don't forget, all over what? 10 minus 3 what? Factorial. So this simply means, what is 10 factorial? 10 times 9 times 8 times 7 factorial. Let's stop at 7 factorial. 7 factorial also means 7 times 6 times 5 times 4 times 3 times 2 times 1. But let's stop at 7 factorial so that we won't get confused. So we now have 3 factorial. What is 3 factorial? 3 times 2, right? So here we have 10 minus 3 factorial. So what is 10 minus 3 factorial? That is 7 factorial. You understand? 10 minus 3 is 7. So let's now divide this 7 factorial divided by what? 7 factorial. What are we left with? Let's say this is 6. 3 times 2 is 6, and 10 times 9 times 8 is what? 720. So we have what? 720 divided by what? 6, which is what? 120. Which is what? 120, which is what we got earlier. So I think I wouldn't want to be much verbose on this. I don't want to. I just want to take it gradually so that you won't get confused. And please always revisit your past lessons. Always write down notes. Note taking is important, even especially in programming. Please, note taking is important. It's very very important. It's key. So please always revisit your notes, and by the time we start giving examples and by the time we start giving exercises, you won't get confused. And in the next class, we're going to be entering a new topic, and it will interest you to know that the new topic is what? Symmetry. We are going to be doing what? Symmetry. So I really appreciate your time, the time you've given for you to participate in this lecture or this particular lesson. So thank you very much for attending this lecture, and God bless you. Amen.